Okay, hello, welcome everybody. My name is Sharon Bonney. I'm the Executive Director for the Coalition on Adult Basic Education. It is my privilege to welcome you to today's webinar. Right now, I want to take a minute before we get started to turn this over to Robert Breitbard, who is our sponsor of the day from Burlington English. And the reason I want to turn it over to them first is because due to their sponsorship, this webinar is free of charge to all of our members. So Robert, if you'd like to have a minute here.
Well, hello, everyone, and super excited to be with you all. I know you're going to really enjoy what Eric and Solange and Mark are presenting today. And again, thanks to all of our friends at COABE, and look forward, if you stick around, we have a intermission and then something quickly toward the end, where we'll talk a little bit more about particularly everything that we're hearing going on with WIOA and exactly how Burlington English is a perfect fit for that. So thank you to all of our great presenters here, and I'll turn it right back now to our friends at COABE and Sharon Bonney. Thank you.
Great, thank you. Thank you, Robert. I'm going to take a minute here to share my screen. Okay, so hopefully you all can see this. Welcome to today's webinar, Exploring Algebraic Thinking in a Teacher's Circle. All of webinar participants will receive a certificate of attendance, and you'll also receive an email tomorrow, which will verify your attendance, along with all the materials, which will be posted to our COABE website. Additionally, you can go to our Adult Educators repository, and not only will the materials be posted there, but also you'll be able to download them and access them and post comments and questions. I wanted to also take a quick minute just to mention that we have our virtual conference October 26th and 27th, and our national conference March 25th through the 28th in Phoenix, Arizona. And more information will be coming out very shortly on both of those. If you're not aware, we also have a national public awareness campaign, Educate and Elevate, Investing in America's Future, which we're doing jointly with the National Council of the State Directors of Adult Education, with our intention being to impact all 55,000 adult educators in the system of adult education. And also we're trying to work with legislators to impact funding. So that's why we've launched this campaign. Also, I just wanted to mention that we have a journal, and we're in our 40th year of publishing that journal. That is free to all members. You can download it on our website, or you can purchase it if you've got a hard copy. You can purchase that as well. In that, the spring 2017 issue, Eric Appleton, who's one of our presenters, who I'll be introducing in a minute, wrote an article on problem posing and problem solving in a math teacher's circle. So ties in beautifully with today's webinar. Okay, as I mentioned, this webinar is sponsored by Burlington English. And now, the moment we've been waiting for, I wanted to introduce our presenters. Eric Appleton, he is a math and science professional developer for SUNY Adult Literacy High School Equivalency Program. Before going there, he worked in an education program for formerly incarcerated individuals. He's taught all subjects in adult education and high school equivalency and has been working in adult education since 1999. So just a few years after I graduated from high school, this gentleman got his start in adult education. Mark, Solange, and Eric are all founding members of the New York City Community of Adult Math Instructors. Our next presenter, Mark Trushkowsky. Mark is the Math Professional Development Coordinator for SUNY's Adult Literacy Program. Mark's career in adult education began in 2001 in a basement classroom at a community college in Queens, New York. After 9 years of teaching adult basic education classes in all subjects and high school equivalency math, Mark joined the SUNY Adult Literacy Professional Development Team, where he does professional development for adult learning centers, teachers across the SUNY system. Mark, Solange, and Eric are all founding members of the New York City Community of Adult Math Instructors, and Solange Farina. Solange, I apologize, I know I didn't get your last name quite right. Solange is a lead teacher instructional coordinator in the Adult Basic Education Program at the Center for Community Education and Workforce Development in the Bureau of Manhattan Community College. Solange has been teaching adult basic education for over 25 years. She has taught and offered professional development in all subject areas of the high school equivalency program along with ESOL. And she also works with Mark and Eric and is a founding member of the New York City Community of Adult Math Instructors. So with that, I would like to now present to you our webinar presenters. And I'll turn this over to Mark. Mark, we can't hear you.
Yeah.
Now we can.
Yes.
Okay, good. I'm just getting my sharing screen ready. Okay. There we go. So I'm going to be driving, but Solange is actually going to start us off. So I'm going to turn it over to Solange.
Okay. First, I'd like to welcome everybody to today's webinar, Exploring Algebraic Thinking in a Math Teacher Circle. We're really excited to be here and to share some of our thoughts with everybody. What we're going to do is take you through the steps of one of our typical CAMI meetings, the New York City Community of Adult Math Instructors. Before we start doing that, I want to just focus your attention to two of the hashtags that you'll see on the screen. We have the hashtag NYC-CAMI and ANN Math for the Adult Numeracy Network. We would invite you not only to share some of your thoughts in the chat program here, but also to take pictures of some of your thinking as we do math problems later on in the webinar, and tweet them if you can so we can see them on Twitter and share them. And throughout the webinar, we invite you to post your questions, comments, and photos of your work, and have pencil and paper ready. This is a very active webinar, and you're going to be doing some work throughout, so please be comfortable and be ready to have some fun. So in our agenda, we're going to, again, take you through the steps of a typical CAMI meeting. We're going to start with some problem posing. Then we're going to solve a problem. We're going to present some solutions, and at the end, make some connections to our own thinking. As we go through each phase of today's session, we want you to think about how each activity helps motivate student learning. In this workshop, you will use visual patterns to develop algebraic thinking and leave with some teaching resources by the end. We hope that you'll get a little bit of a taste and experience of the possibilities of working in a math teacher circle. And of course, we hope that you're going to enjoy doing some math and have a lot of fun. Now I want to tell you a little bit about our teacher circle, CAMI. Basically, we're a group of teachers from different programs in New York City. We get together about once a month and we do some math and we talk about our teaching. We have a problem-solving approach to teaching math. We usually only tackle about one problem per meeting, so it could take about an hour and a half to do that problem. Our problems are open-ended, they're non-routine, there isn't an obvious solution method, there are multiple strategies. For all of us involved in CAMI, we believe that getting together in a group serves a dual purpose. We want to both improve our own math content knowledge and focus on deepening our own knowledge of math, but also give us time to reflect on our thinking. We believe very strongly in the power of adult ed teachers doing math together, making connections between our own learning and our teaching. So in this webinar, we're going to go back and forth and put on both our teachers' hats and our students' hats. So we're going to think of ourselves as learners and think of ourselves as teachers. One of the primary purposes of working in our math circle is to put ourselves in a position of being students so that we know what that feels like and keep learning. Now we're going to show you this quote by Diana Lambdin, a past president of NCTM. Take a few seconds to read this. So we wanted to present this quote because this is an idea that is really foundational for us at CAMI, that learning is constructed in a social setting through problem solving. It's an active process centered on student thinking and the doing of mathematics. What we want to do as teachers is to provide opportunities for learning through good problems, good questions, facilitations, but the students are the ones that are doing the learning, and they do that through struggle and wrestling with mathematical ideas. They have to do the work of mathematical thinking. If the teacher is doing all the talking and explaining, then the students are really deprived of the chance to make meaning in mathematics. So think about that for a moment. Think about this quote. How does this resonate with you as a teacher and as a learner? You can, of course, give us some comments in the chat part of the screen, but now we're going to actually move on to do some problem posing.
Good afternoon, everyone. This is Mark. So before we start solving a math problem, every CAMI meeting starts with some problem posing, where we explore a situation and create the problem. So I'm going to show you a figure, right? We're going to spend some time warming up our minds and loosening up our observation skills. So for the next slide, I'm going to flash something on the screen, and all you have to do is look at it, right? And I'd like you to think about, have the question in your head, what do you see? Okay, try to keep a visual image of it in your mind. Okay, so take a look at your screen. Okay, so now I'd like you to take about 20 seconds and describe, what did you see? And you can type it right into the chat, but what did you see and what did you notice when you were looking at that figure? What did you see? Okay, so now we're going to look at a second picture. So you can stop typing for a moment, take a look at your screen, and I'm going to ask you the same two questions. What did you see and what did you notice after we look at this second figure? Okay, again, I'd like you, what did you see in the second figure? What did you see? What did you notice in that second slide that I just showed you? Don't worry about being right or wrong, just write down what you remember. You can also, of course, comment on what other people are noticing also. But take about 20 seconds and type in, what did you see? What did you notice? Okay, we're going to do this one last time. And again, I'm going to show you a slide, and I'd like you to take a look at it. Here we go. And for one last time, take 20 seconds and write down anything you saw or anything you noticed. No, these are fantastic. Keep those comments coming. Okay, so let's start off by taking a look at some of the things that people noticed. One is bigger than the other. There are 10 squares, there are 17 squares. It looks like an offset square, it looks like an offset rectangle. It's growing larger. There's one additional square added. We're looking at the second, the third, and the fourth figures. There's no figure 1. The number of squares is growing. Again, they're not quite rectangles. It's like something's offset. And so one other thing that that I see at least one person has noticed is there's no question, there's no problem to solve. We haven't asked you to do anything other than to see and to notice. And so before we continue, I wanted to make explicit for a moment about why we start by asking students and why we start at CAMI to make observations without a specific question to answer. Because that's something, again, that we do both in our classrooms and at CAMI meetings. But by asking, what do you notice, there's no right or wrong, right? It's just what you see. It's accessible to all students, and it promotes sense making. It slows students down, so they have to understand the situation before trying to answer a question. We all know sometimes students get a math problem and they start taking numbers and doing something with them before they fully understand what's going on. And so this prevents them because there's no problem to solve. And along those lines, it helps to balance and equalize contributions in the mixed level math class, which all students have. Students who can't jump ahead and start solving the problem, leaving behind other students who cannot, because there is no problem yet to solve. We're all just right now brainstorming and making mathematical observations. And one final thing that we really like about having this as kind of a launch to our activity is it allows teachers to really draw out student thinking, to be able to build off of student ideas and student ways of thinking. You know, you've all shared different ways of looking at this and seeing that, and those are things that we can connect back to. Connected to that Diana Lambdin quote that Solange read, you know, understanding takes place in the students' minds as they connect new information with previously developed ideas. So now we're kind of sharing what those previously developed ideas are so that we can build forward. So now let's explore some of the patterns in the whole sequence, right? Looking at all 3 figures at once. So take a look at this statement. As the figure number changes, blank also changes. So I'd like your help with this. What could fill in that blank? As the figure number changes, blank also changes. So take a minute or two and consider how the figures are changing from one to the next, and write down in the chat everything you can think of that could fill in that blank. These are all great. Please keep these ideas going. I'm just going to start reading some of the ones I see. As the figure number changes, the total number of squares also changes. As the figure number changes, the height, the number of rows also changes. And so what does it mean to say the height is changing? What is the height? Because there are different ways of talking about the height of each of these figures. So for the sake of our discussion, let's agree that when we're talking about the height of each of these figures, we're talking about the tallest column in each figure. So for example, the height of figure 2 would be 3. The height of figure 3 would be 4, and so on. So that was, the height is changing. The width is also changing. It's getting wider, right? So again, it's the same idea. What is the width? Let's say for the sake of discussion that the width of figure 2 is 4, and the width of figure 3 is 5, and the width of figure 4 is 6. So they're increasing by 1. As the figure number changes, the area is also changing. The perimeter is also changing. The number of missing squares, if we imagine this as a rectangle, there are some squares that are missing, and that is changing. The bottom right, this is interesting. Someone said something that's not a change. That's actually a constant, which is the bottom right corner is always 1. There's always one little bite taken out of this. Okay. So we're going to move on. These are all great observations. These are great things that we see. And we just spent some time looking for patterns and change in this sequence. And one of the things that patterns of change enable us to do is make predictions. You know, so we've been gathering data so that we can make predictions about what might come next. So let's use some of those patterns, the height, the width, the number of boxes, anything you can, to create the next figure. So we're looking right now at figures 2, 3, and 4. So take a minute and draw the next figure. What would figure 5 look like? I'd like you to actually draw it out from wherever you are. If you can take a picture and tweet it if you're on Twitter. Excuse me, the hashtags are in the top corner. So take a minute and draw the next figure. I see as some people are drawing, they're actually also writing descriptions of what it might look like in the chat. That's fantastic. You guys can keep doing that. If anyone wanted to take a crack at how many boxes, how many squares there would be in that 5th figure, that's something you could think about. Excellent. There's some debate, which I love. So I just want to point out, this is an activity that we would do with students, but that we would give them more time, but we're going to move forward. So please continue your work and continue sharing, but we're going to move forward to the next slide. And here we have our sequence with figure 5 added. So when I ask you to complete the statement, as the figure number changes, the blank also changes. You observe many different ways that the figure is changing. So let's use some of those observations that you made to verify the 5th figure that's here. So one, the height is 6 rows. This is a shape is 6 rows high. There's 6 squares. It's 6 squares tall. So that follows with that pattern. The second figure was 3 squares tall. The height of the third figure 3 was 4. The height of figure 4 was 5. So the height of figure 5 is 6. They're each going up by 1 each time. So that continues along with the patterns that we noticed. Same thing with the width. The width of figure 2 is 4. The width of figure 3 is 5. The width of figure 4 is 6. And so here we have the width of figure 5 being 7. There are 3 in the top row, where there are in the other 3 figures. The bottom right corner is missing. Okay. So we now have 4 figures in the sequence. Right, we can certainly continue and check against the other observations, but we have 4 figures in this sequence. We have figures 2, 3, 4, and 5. And we've spent some time looking at the sequence in a couple of different ways. So now what we'd like you to do is pose some questions. And again, you can post them in the chat or you can tweet them out using the hashtags that are at the top of the screen. But what are you curious about? What questions do you have? What are you wondering? A couple of people have already started to ask questions. I saw someone say, what would figure 1 look like? So pose some questions on your own. Try to focus on mathematical questions and take a minute and try to write some questions. And for now, please focus on posing questions. I know it can be really tempting to start working on a question, especially when it grows out of your own curiosity, but please just allow yourself for now a moment to wonder, right? Pose some questions. Thank you. Keep those questions coming in. Mhm. So please keep writing questions. What are the questions you'd like to solve? What are the things you'd like to work on? And as you add questions, I just wanted to share a few questions that have come out of looking at this specific pattern, both at a CAMI meeting and at a COABE workshop. So you'll see some similarity between some of the questions that you guys asked. And you can see there's really a wide range in the possible avenues that we could take this visual pattern. What does figure 1 look like? What does figure 0 look like? I know I'm looking at the questions that are coming in on your chat. These are great. Can there even be negative numbered figures? Like Cindy says, does everyone see this as a large rectangle with bytes taking out of the rectangle, or a rectangle with a block added to the top right? That's interesting, right? And the answer, which of these is it? It's both. But she's curious as to if other people are seeing it in the same way that she is. So these are great. You can pose a little bit further, a few more questions. There's some really great questions that have been posed here. I wish that we could explore them all. But for the time that we have together today and the limitations in our ability to interact, we're actually going to ask everyone to focus on the same question, at least at first. So I'll tell you what that question is in a moment, but I want to let you know a few things first. We're going to give you about 5 minutes to work. When we do CAMI and in our classrooms, we use a lot of group work, but we always start with some time for people to work independently, to kind of wrap their own minds around and kind of start developing their own methods. So we're going to give you about 5 minutes to work. If you can, again, take a photo of your work. You can post it on Twitter using the 2 hashtags. Please, this is important. Do not put your answer in the chat, at least not yet. Let's give everybody a chance. So if you finish, if you do finish and there's more time on the clock, what I'd actually like you to do is go back through the chat and start exploring any other question that interests you. It might be a question that you've posed, or it might be a question that somebody else has posed. So if you do finish, don't answer it, but go back and keep working on a different problem. So let's take a look at our question that we're going to focus on. How many squares would be in the 10th figure? How many squares would there be in the 10th figure? We have figure 2, 3, 4, and 5. So you can go ahead and get started. If you have any questions, please use the chat. But remember, at this point, please do not share any answers that you come up with. And I'm going to give you some problem solving time. Okay, thanks everybody. I'm going to turn it back to Sharon now for a word from Robert from Burlington English. And when we come back, Eric will take over and explore some different solution methods to this problem. Thanks everybody.
Excellent, thank you, Mark. So as I mentioned earlier, we're just delighted that we have Burlington English as a sponsor, because that means that this webinar is brought to you free of charge. Otherwise, you'd be paying for it, or COI would be. So thank you to Burlington English for your sponsorship. And Robert, I think you had a few words you wanted to say at this point. We'll give him just a minute here. Well, I'm guessing Robert's having some technical difficulties, so we're actually going to move to the next phase here. So I'm going to hand this back to Mark.
Okay, excellent. So I am going to actually turn it over now to Eric, who's going to look at presenting some solution methods, which would be the next step in a CAMI meeting for this. Eric?
Hi, everyone. Mark, I think we still need to share your screen. I'm ready when we get the screen up. Okay, great. So hi, everyone. I just wanted to, I guess I start by talking a little bit about our CAMI meetings. This is the name of our math circle. One of our routines in our meetings and in our classrooms is to work in small groups, put our work in newsprint, and present our solution methods to the large group. We share multiple solution paths that can help us understand mathematics from different perspectives. The reason why we do this is there's a number of reasons for this, but students sometimes think there is just one way to solve a problem. And they probably learned that from us, unfortunately, because teachers often demonstrate a standard way students should solve a problem. The issue with this is that students, if they don't come up with this method right away, they often put their pencils down and wait for what they think of as the real way to solve it. And you've probably heard, I'll just wait for you to show me, when students don't have a path forward. So we want to help students pick up the pencil and try again, and build their persistence along the way. So when they're facing problems in different situations, that they have different tools in their toolboxes. We believe it's important that students learn to see mathematics as a place to practice creativity and invention. So there are multiple approaches that could work with visual patterns, including using manipulatives, drawings, tables, graphs, written rules, symbolic rules, and we've seen some of that already in the chat. Each of these representations has strengths, and there's different considerations that we might think of when we use them, and so we're gonna look at some of that. But we want students to develop fluency with different methods and see connections between them. Today we're going to simulate the solution sharing process that we use in our meetings in our classrooms and look at how different people have approached the visual pattern that we're looking at today. So first we're going to look at how a teacher found the number of squares in the 10th figure by drawing each of the figures. So I guess I'm wondering, how many people out there used a strategy like this to determine the number of squares in the 10th figure? Is this something you imagine your students doing? Let us know in the chat. Meanwhile, to talk a little bit about this visualization here, we can see that the teacher saw a pattern in the figures and used this knowledge to continue drawing the series, and then at the end counted the number of squares once they got to the 10th figure. You can see in figure 10 how the teacher counted the number of squares in each row and then added them up to get 122 squares. By the way, is that the number that you all got? Let us know if you did or if you got something different. And so what are the benefits of drawing to predict the growth here? What does it allow you to do? Well, first of all, for students, it's an accessible technique. Drawing allows everyone to get started. We usually will have students draw the next figure in a series even before asking any questions, about the visual pattern. Drawing the visual pattern can also give you a concrete understanding of the growth and why it's happening. You have to understand the pattern in order to draw the next figure in the series, and I'm sure you found yourself looking back at previous versions of the figure in order to make predictions about what the next one would look like. For example, I can see that in each figure, I make the bottom row 1 square longer than in the previous figure, and I can use that to guide my drawings as I continue to make them. Drawing is also reliable. If you understand how the growth is happening visually, you can be confident in your prediction of squares for the number of squares in figure 10, for example. And drawing every figure out, though it's time consuming, it gives you a lot of data. In this series of drawings, we have the number of squares in the figures 2 through 10 if we count them, and this can be helpful for finding patterns in the numbers. So we think it's important to let students continue to use drawing as a solution method even as they incorporate other strategies. We don't believe that there is a hierarchy of solution strategies. We want to help students build their toolbox of problem-solving strategies and develop an awareness of when each strategy makes sense, so they're flexible in different situations. They all can be useful depending on the situation or the question that they're trying to answer. But maybe there's some considerations when thinking about drawing. Clearly, it can take a long time to draw each figure. So if we wanted to know how many squares there are in the 20th figure, for example, the student would probably get exhausted at some point drawing every figure and would want a more efficient method to determine the number of squares. So by the way, do you think you could draw the 20th figure without drawing all the other figures in between? Or would you switch to a different strategy? Curious about that. Another thing about drawings is that students might not notice patterns in the numbers if they only work with the visuals. After the students have drawn a series, we might ask, how many squares are in each figure? What do you notice? How many squares do you think there would be in the 11th figure, say? At this point, they might want to start organizing the data and looking for patterns in the numbers. Which brings us to a different approach, which is a table of data. Wondering if anybody out there made a table to find the number of squares in the 10th figure. Do you think your students would use something like this? Let us know in the chat. In this case, the teacher counted the number of squares in each figure, then organized them in a table and looked for patterns. In our classes, we often ask students to create tables after drawing a few visual patterns in a series. Based on the table, how many squares do you think there would be in the 11th figure? I'll give you a second to think about that. Go ahead and throw an answer in the chat. How many squares would there be in the 11th figure based on this table? Okay, I'm seeing some answers come in. Mark, did you do this?
I did, Eric. I saw a pattern in the number of squares in each figure. So figure 8 has 82 squares. Figure 9 has 19 more than that. Figure 10 has 21 more than that. So that I figure figure 11 would have 23 more than figure 10. So 122 plus 23 would be 145.
Okay, thanks, Mark. And that seems to agree with a lot of the answers I'm seeing in the chat. And how about on the other side of the table on the top end, is how many squares do you think figure 1 would have? Go ahead and let us know. But I'm going to move on, and you guys can keep talking about that through the chat. But thinking about a table, what does a table allow us to do? The table shows the function relationship between the figure number and the number of squares. We could think of this as an in and out table. On the left, the figure number is the input for the function, and the number of squares on the right is the output. So we might look at patterns vertically in the number of squares, as this teacher did. We can see a pattern in the differences between the number of squares in each figure, 7, 9, 11, 13, etc. But you can also see that the difference is not the same each time. It's not a constant rate of growth, but there is a pattern. There's a difference between, the difference between the number of squares is growing by 2. And this vertical pattern can be helpful for predicting the number of squares in the 11th figure, and the 12th figure, and the 13th figure, for example. And so what are some of the considerations in making a table as a solution strategy? well, what if we wanted to know the number of squares in the 100th figure or the 500th figure? We could continue the table. We know it works. However, it seems like it would take a long time to do that. There's got to be a faster way to do this. So we might want to ask, what are the patterns in these numbers if we look horizontally from input to output rather than vertically? How do we go from figure 2 to 10 squares? What's happening to number 3 to produce 17, 4 that makes 26, etc. When we look at patterns horizontally, we're looking for a rule to go directly from the figure number to the number of squares. And so maybe a combination of operations occurs to you already that would produce 10 squares for an input of 2. In order to find a rule for this, or a recipe, as I heard someone say, or read someone say in the chat, I really like that. Solange, Mark, and I went back to the visual to see how the figure number shows up in the pattern. In the next few slides, we're going to show you how our different ways of seeing results in rules for the number of squares in any figure. As we present, you might check our rules to see if they produce the correct number of squares for each figure. I'm going to hand this over to Mark.
So one strategy I try when I'm looking for patterns in a figure of a visual pattern is to look for instances of the figure number appearing in each figure. This doesn't always work, but sometimes it does. So for example, here, when I look at the second figure, I notice groups of 2. Then I notice the same thing in the third figure. They're groups of 3. So for both of these figures, I have groups of the figure number and then 2 more squares on top. And the same is true for the fourth figure. I have groups of 4, and then I have 2 more on the top. So I don't want to keep having to repeat the words figure number. And because I see a connection between the figure number and these groups, I don't have to. I can say that whatever the figure number is, I can divide the shape up into groups of that number with 2 more squares on the top. So I'm going to use the variable n to stand for whatever the figure number is. And to be consistent, let's put in that constant of 2. Each one of these has some number of groups of the figure number plus those 2 more squares on top. So let's add those. So I'm still not sure what I'm looking at yet. I'm still not sure that I can go from the figure number to the number of groups. I know that whatever the figure number is, I'm going to have some number of groups plus those 2 more squares on the top. But how do I get from the figure number to the number of groups? So what I do is I write down what I have. So I have 4 groups of the figure number plus 2 in figure 2. I have 5 groups of the figure number plus 2 more in figure 3. And I have 6 groups of the figure number plus 2 in figure number 4. So I notice that the number of groups is always 2 more than the figure number itself. So I have 4 groups of 2, 5 groups of 3, 6 groups of 4. So whatever the figure number is, I'm going to add 2 to that number. That's my n plus 2. Figure number plus 2 is the number of groups. Then I'm going to multiply that by n, because I have groups of the figure number. And then I'm going to add those extra 2 squares on the top. So the number of squares in each figure can be found by multiplying the figure number by 2 more than the figure number, and then adding 2. So let's take a look at what that would look like for the 10th figure. Since we're talking about the 10th figure, I know that we're going to have groups of 10. Since I noticed there are n plus 2 groups of the figure number, I know I'm going to need 10 plus 2, or 12 groups of 10. That gives me 120 squares, and then I add my 2 at the top, and I get 122 squares. Now I'm going to turn it over to Eric, who's going to explore a different way of seeing the seeing the figure.
So when I, when I looked at figure 2, I saw a 2 by 2 square in the bottom left-hand corner. And I saw similar squares in figures 3 and 4, also on the top left, I'm sorry, in the bottom left-hand corner. So figure 2 has a 2 by 2 square, figure 3 has a 3 by 3 square, figure 4 has a 4 by 4 square. The side length of this square is the same as the figure number. So it's the figure number squared, which I could refer to as n squared. I then saw 2 more groups of n as columns on the right side of each figure. 2 columns 2 squares high, 2 columns, 3 squares high, 2 columns, 4 squares high. Each of these columns is n squares high. I saw the 2 squares left over in each figure as the constant plus 2. So my expression for each figure was the same, n squared plus 2n plus 2. And here's my rule for finding the number of squares in each figure. The number of squares in each figure can be found by squaring the figure number, adding 2 more groups of the figure number, and then adding 2. And so then for the 10th figure, I started with a 10 by 10 square, and then I drew 2 columns of 10 in these positions on the right, and then I drew 2 more squares on top. And so I calculated the number of squares in the 10th figure as 10 squared plus 2 times 10 plus 2, which all adds up to 122. And I'll pass this to Solange.
Okay, so similar to what Mark and Eric did, I also was looking for what is constant and what is changing in each of the figures. The first thing that I noticed is that the top row always has 3 squares. The next thing that I noticed is I went and looked at the bottom row, and I realized that the bottom row is always the figure number plus 1. Then I was exploring what happened in the middle rows. And I realized that the number of squares in each row was always 2 more than the figure number. So it would be 2 plus 2, or 3 plus 2, or 4 plus 2. However, the number of rows was 1 less than the figure number. So there's only 1 row in figure 2 and 2 rows in figure 3. And then I realized if I put all of this together, I would get my total. So I'm adding the 3 plus the n plus 1 of the bottom row, plus the n plus 2 times n minus 1 for that middle chunk. And that would get me my total. So now I'm going to show you what that would look like in the 10th figure. So again, there's the 3 at the top. The bottom was the 10 plus 1, so I know that there's 11 in that bottom row. And then for that middle chunk, I know that it's 10 minus 1 gives me the 9 rows, but 10 plus 2 gives me the 12 columns. So again, I'm doing 12 times 9, plus 11, plus 3, and that's how I got to the 122. So at the end of a CAMI meeting, we present our solution strategies like we just did, but we're really getting to a point where we want to spend some time reflecting on our work and connecting it to our teaching. So we want to think about some questions that we ask ourselves as teachers. Would we do this problem with our students? What would have to come before this problem? How would we scaffold it? What would come after? What questions would we ask when students get stuck? If we have lower level students, what's a simpler version of this problem? Are there similar problems that are more accessible, but that would still get to the same algebraic thinking? What goals do we have in teaching this problem? What do we want students to learn? And we noticed some of that in the chat. A lot of you were asking, you know, what is the point? Where, what are we, you had some good questions about what is the goal of doing the problem, but also noticing that the visual thinking led to algebraic thinking. I want to spiral back to the Diana Lambdin quote, that learning takes place in students' minds and that they need to construct their own knowledge and build bridges to new problems through problem solving. We want students to build a toolkit of habits of mind and solution strategies that they can apply to new situations. As teachers, we can't anticipate every problem they're ever going to encounter, whether it's in college or on the task exam or whichever HSC exam is being given. And we can't and we shouldn't try to do that. But what we can do is help students build their mathematical thinking repertoire, as it will, and help them solve new problems that they're presented with. So at CAMI, some of this thinking about our teaching leads us to anticipate places where students will get stuck and think of questions and prompts to move student thinking along. A sample of some of the types of questions we might ask, you'll see on your screen, and you can take a minute to read them. The aim is to focus students' mathematical thinking and not simply to get at a numerical answer. You know, it's not just about the correct answer. We want them to actually be thinking like mathematicians, and we also want to think of good extension questions. We often talk about the richness of low entry, high ceiling problems, problems that are accessible to all students in the class, but that can lead to deepening mathematics over time. So some of the questions we might ask to extend the problem might be what-if questions, such as if you have 258 squares, what figure number is that? So this would make students kind of work backwards a little bit. It focuses their thinking. And it builds fluency with doing and undoing, which is really critical in algebra and will help them later to understand equations and more formal notation in algebra. As Marilyn Burns says, algebra is the generalization of arithmetic. Algebra is a huge mathematical gatekeeper in U.S. schools, and we hope that by building students' proficiency with visual patterns, that they start traversing the bridge towards algebra. They need multiple experiences with these types of problems and time to struggle and work through them. We want them to lay a lasting foundation for algebraic thinking. As the slide shows, there are a number of key algebraic concepts that can be introduced or explored through problems like the one we gave you today. It is valuable to present these types of problems throughout an algebra class so that students can build on the concepts and extend their mathematical knowledge. For example, I might start with a linear pattern and a linear visual pattern before getting to a quadratic one like we did today. Those are the types of decisions we make as teachers. It is the art of teaching to have our own repertoire of rich problems at our disposal, our own toolkit, and to know what order to teach the problems and what we want students to learn from them. We believe that professional development, like teaching, takes time. We believe a teacher circle like CAMI helps us to be better teachers and wrestle with our own deepening content knowledge and our pedagogy and teaching toolkit. We also learn, like students, we learn best in a social setting and with our peers. So we try to give ourselves the math class that we would most wish to have, which is full of engaging, rich problems. And we hope we were able to give you a taste of that, a small taste of that today, this afternoon. In closing, we want to leave you with some resources and information. As Sharon mentioned in the beginning, there's an article. Eric, Mark, and I, along with a couple of other people, co-wrote an article for COABE, which was in the spring journal. So you can read that. We invite you to read that. We also want to give you access to the CUNY High School Equivalency Math Curriculum Framework on functions in algebra, which you could find at the website above. This framework has 2 lessons specifically on visual patterns. One is an open approach like the one we use today, that we modeled today, and the other is more scaffolded and focuses on students developing specific understandings, namely how and why we use algebraic notations to create generalizations of situations by focusing on what is changing and what is staying the same in those situations. We also want to direct you to visualpatterns.org, Fawn Wynn's site. There are over 200 visual patterns on this website, and one of them is the one that we gave you today. So we want to give credit to the website for that. And there are linear patterns, quadratic, cubic, all levels of visual patterns. We also want to invite you to come to our website, newyorkcitycami.org. Like we mentioned earlier, we do meet once a month. We post all our problems and our meeting write-ups and descriptions of our approaches on our website. So you can, even if you can't come to one of our meetings in New York City, you can try out the problems. You can add notes to the website. You can follow us on Twitter, and we do live tweet our problems monthly. And of course, we invite you to start your own teacher circles. The three of us are also part of the Adult Numeracy Network, which is a national organization dedicated to improving math instruction in adult ed. You can become a member of ANN by going to their website. And as mentioned at the beginning of this webinar, the COABE Adult Ed Repository is a place for lesson plans, conference presentations, and professional development resources. We want to thank you very much for participating in our webinar. In the few minutes we have left, we invite you to ask questions in the chat, and we'll try to address them in the few minutes we have remaining. And we also have our personal and work emails on the screen, so you can always email us directly.
Thank you, Solange. One thing I'm just going to jump in for a second because I see that there's a few questions. Sharon, if we have time to answer them.
Yes.
There's a few questions. Ahead. Great, thank you. There's a question here, Mark or Solange, maybe one of you want to take this on. The question is about lower level students and how do we use visual patterns? Maybe I'm sort of editing a little bit, but how would we use something like this with a lower level student or lower level class? Either of you want to take that?
Well, I'll start it off, and Solange, you can certainly jump in. But I would again refer you guys to the that resource, the Collect Ed framework post, because the scaffolded lesson starts with a linear visual pattern. So and it has a very scaffolded set of questions. So that's one way that you could do, although I would say also that, we've done the open-ended approach with lower level students as well, and I think that there's a lot that they can engage with. But if you're looking for something to kind of think about what other possibilities might look like, I would refer you guys to that problem. Solange, did you?
Yeah, I'm going to jump in and also suggest that you use manipulatives. For a lot of students, moving from the concrete and then later on to the abstraction really helps. So you can use color tiles for this, or you can cut out squares, from cardboard, depending on what resources you have. But using manipulatives or grid paper, but it really helps students to build the shapes themselves. And then from there, they can make a table and etc.
Another question that came up is where this information can be found. I'm assuming like where the PowerPoint will be posted. We'll be sharing that with Sharon and with COABE. And Sharon, where will people be able to find this PowerPoint?
So that's going to be on the Adult Educators repository. I'll put the link right in the chat box here in just a second. What's really nice about that is people can go in and not only download it, but they can also post questions or in comments as well as to rate it. So that's where that will be. And it's on the COABE website, but I'll put the actual link. Give me 1 second here.
And one last question that I see, unless there are others, but one question I see, Mark, there's a question that, why did we use see notice rather than notice and wonder? I'm not sure if everyone out there is familiar with the routine of asking students, what do you notice and what do you wonder? This is something we use quite often. But in the launch for this activity, you started with what do you see and what do you notice before asking the group to pose questions. Did you want to talk about that, Mark?
Sure. Just very briefly, we did ask you guys to wonder, but when I asked you guys to pose questions, but we wanted to separate those two activities. Sometimes we do them at the same time, but we wanted to really focus on the noticing because we wanted to make sure and draw out all the different ways that people were looking at that pattern, just to kind of help people see them, because we're not all in the same space, and so we wanted to just make it very clear, make sure that we were all just focusing on what we saw and then moving to what we were wondering. So we wanted to do that same thing, but we wanted to do it. We wanted to focus everybody's attention at one of them at a time.
And I will post this is Eric, I will post a link to the Notice Wonder protocol if you're interested. We found it very useful. I just put it in the chat. And I guess that's all for the questions that I see. Is there anything else anyone else?
And then I just wanted to take a minute here to mention that everybody that attends is going to get their certificate of attendance. And then also I wanted to give Robert Breitbart of Burlington English an opportunity to speak.
Hi there. That I thought that was to paraphrase Fleetwood Mac. You make learning fun. I just could not believe how much from a math challenged person that I am, just how great that was. I really, really enjoyed that. That would make Euclid proud. So again, to everybody, yeah, somewhere my algebra teacher from ninth grade is amazing. I remember that one. But again, to Solange and Eric and Mark, and that was really fantastic. I'd like to say also that I think Burlington English does a really fantastic job of making learning fun as well. And particularly, we make something as super high pressure as WIOA as fun as it can be. So if you can imagine every one of your adult learners having his or her own personal career counselor, and that's what Burlington English really gives for you. It's a multi-platform, it's multiple levels. We have a new basics course coming out. It's distance learning, it's lab, and it's everything a teacher needs actually also to have a total connection, a true hybrid and blend. So it's everything that you need it to be. But specifically, could you imagine, like I say, every one of our learners, even at beginning levels, going through those career pathways. And then as they're narrowing down their career pathways, then, to actually be taking a look at careers that would interest them. And like I say, even at the beginning or intermediate, before they're ever ready, to launch into one of these like IET programs we're hearing so much about. Wouldn't it be really neat if they were able to explore all of these and all of these career clusters, make a really good IET decision down the road? And I've got a dental meeting coming up next week, so I like to use this one to keep very focused. And again, not just getting students ready for IET, but then when they're in it, support them through these as well as IELCE. So all of this can be found in Burlington English. It'd be well worth your while. Please visit us at burlingtonenglish.com if you'd like to find the Burlington teammate closest to you right here, burlingtonenglish.com contact, and all of the rest of our information. So on behalf of all of my colleagues in Burlington English, thanks so much again to our friends in New York and to COABE, and I'll turn it back over to Sharon Bonney. Thanks so much.
Wonderful. Well, thank you everybody for joining us. Thank you. We had over 225 here on this webinar, so an excellent turnout. Thank you to our presenters, and Solange, Eric, and Mark, you guys did a great job. Thank you so much, and we look forward to seeing everybody at the next virtual conference, which is October 25th and 26th, and the national conference, which is March 25th through the 28th in Phoenix, Arizona. So in the meantime, thank you all, and we'll stay in touch. Bye now.